Hello, everyone. My name is Jalaj Maheshwari, and I'm a research scientist at CHOP. I'm a mechanical engineer by background and have investigated several different areas of pediatric occupant safety, employing different methodologies such as computational modeling, HD and human volunteer sled testing, driving simulator research, naturalistic driving data analysis, and human factors research. My interests are in the application of biomechanics, artificial intelligence, and robotics for safe autonomy. I've been involved in CChIPS as a principal investigator since 2018, but I actually started working on CChIPS projects as a master's student way back from 2016. All right, so the areas of research I'm involved in are number one, human body model evaluation of child restraints, which includes comparing responses of human body models of different ages to anthropomorphic test devices or ATDs in different impacts, restraint characteristics, and naturalistic seating postures to determine how different their biomechanical responses are to ensure better safety system design. Now, these models help us with a deeper evaluation of the human body kinematics and kinetics, allowing for virtual autopsy analysis, which basically means hiding away or peeling away the upper layers of the human body to determine loading of the internal organs by the restraint systems. An example of this is shown on the image on the top right. Where estimating submarining and frontal impacts is shown, which is otherwise difficult to estimate with anthropomorphic test devices or crash test dummies. The second area of research of interest is pediatric vehicular heat stroke, or PVH as we call it, which is an injury and fatality mechanism that has gained a lot of attention in recent years. Now, through CChIPS, we've determined exemplar vehicular heat stroke cases occurring in the real world, evaluated efficacy of technologies for these exemplar cases, and are continually conducting studies to understand caregiver attitudes towards pediatric vehicular heat stroke, their risks for PVH, and their acceptability of PVH prevention technologies. Thirdly, I'm investigating several projects on advanced restraint systems through large-scale parametric studies using both computational modeling and sled testing. We evaluate effect of pretensioners, load limiters, different seatbelt pull-in lengths, the pretensioner firing times, and child restraint seats, among other factors, on pediatric occupant injury response in different impacts, going beyond standard testing protocols to ensure these safety systems behave as intended. Now, an example of this is shown on the image on the bottom right, where traditionally rearward-facing CRSs are safer for smaller children. We observe head contact in the rearward-facing occupant when there's a nearby restrained second occupant sitting. As for future directions, my interests are in evaluating the child restraint systems and advanced restraint systems for diverse pediatric occupants of different anthropometries and ages in different types of impacts, large-scale parametric studies for injury prediction based on crash and different restraint characteristics, and trying to assess pediatric vehicular heat stroke near misses and injuries to add to that fatality data.